Good morning, everyone. Before we get started on the lesson today, go ahead and check your homework. So you can pause it as needed to just make sure you did this correctly. Okay, so here's the first, that was the first two, and then here's the next two. And that last one. Let me know if you have any questions on this. You can send me an email, you can come visit me after school today, or you can even just ask me tomorrow when we're in class. All right, let's go ahead and start today's lesson. Today we're going to be looking at real-world problems, real-world linear equations. Okay. You are going to want to make sure you do this on graph paper because we're going to be graphing these as well. So our learning target is I can write and solve linear equations for real world problems. Okay, so I'm going to do a couple of examples. Here's our first one. I apologize ahead of time. It's quite a bit of writing because I have to write out the word problem. Okay, so a deep freezer is set at negative 25 degrees Fahrenheit. The freezer breaks. And the temperature rises 5 degrees Fahrenheit every hour. Okay, so we are going to write an equation for this, and I'm gonna define your variables for you. So we're gonna let H be the number of hours, and we're going to let T be the current temperature. Now the beautiful thing here is if you're not done writing this all down, it's okay. You can pause it, finish writing it down, and then move on. So the first thing we're going to do is we're going to write an algebraic equation, a linear equation for this, and then we're going to graph it. The nice thing is that you guys already know how to do this. We just haven't done it with two variables yet, but it's a very intuitive leap for you guys to make. Okay, so we have a total, or in this case it's going to be our current temperature. We have our rate times the number of times. In this case it's hours, so I'm going to put hours down here just to, okay, number of hours. In this case, it's current temperature for the total. okay? And then plus your one-time thing, your starting place or initial fee or whatever it is. Okay, so I know you've seen this frame a lot of times. So let's go through what this means. We actually don't know the current temperature because the current temperature depends on how many hours that refrigerator has been sitting. So we're going to leave that as a variable. We're going to call that T. Now what's the rate? Well, the temperature is going up 5 degrees every hour. So anytime it says every or each, that's what's happening over and over and over again, which is 5. Then it says the number of times, or in this case, the number of hours. Well, we don't know the number of hours, so we're just going to put H here. And then what was the starting temperature? It was negative 25 degrees Fahrenheit. I really should have done this in a different color, so I'm going to make it pop out a little bit by just putting a little bit of blue over it so you can see. And then I'm going to rewrite this equation without all of this framework there. This is T is equal to 5H minus 25. So this is the linear equation that represents this problem. Now what we're going to do is we're going to graph this. You know, I don't feel like I did my graph quite big enough, but that's okay. I think we can roll with it. Okay, well, in this case, this is our x-axis, which we can actually say is H for hours. And then this over here is our y-axis, which in this case, we're talking about the current temperature. Now, because you can see that this is all related to fives, I'm going to change my scale. And you will really only need to change your scale on your y-axis. So this will be negative 5, negative 10, negative 15, negative 20, negative 25. And then this is 5, 10, 15, and 20. Okay, well, you know how to graph this. Your y-intercept is negative 25, and then it's going to go up 5 degrees per hour. Well, we're going to assume that the scale here goes by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for the first hour, it goes up 5 degrees. The second hour, it goes up another 5 degrees, and you can see what's happening here. So at 5 hours, the current temperature is 0 degrees Fahrenheit. And then it's going to continue on like this. So now at any point in time, you can use this graph to try to figure out what the approximate current temperature is. So you might be wondering, well, what is going to be the temperature of that freezer after 9 hours? Well, if you go over to 9 and you go up, you're going to see that that current temperature is going to be 20 degrees Fahrenheit. Okay, so that's what's kind of cool about these real world problems. You can see a lot just by looking at that graph. I do want to point out a couple things about this graph before we move on. In this case right here, I'm going to choose a different color too. This is your y-intercept. And in this case, the y-intercept represents the starting temperature of the freezer. Okay, starting temperature of the freezer. And the slope of this line is telling us the rate that the temperature is increasing by. so now our y-intercept and our slope actually means something here, okay, because we've applied it to a context. So I hope this makes sense. Let's go ahead and turn over the page. I want to give you another example, and then I will let you work on your practice. Again, I apologize for all the writing. I know that it's a lot. Okay. So a caterer, if you don't know what a caterer is, they bring food in for big functions. And so when I got married, we hired a caterer to bring in the food and make all the food and serve all the food at our wedding. Okay, so a caterer charges $200, a $200 fee, plus $18 per, oh, you guys can't even see that. I am sorry. You can pause it and get caught up if you want. Per person. Okay, so here's what we're gonna do. We're going to write the equation. I'm gonna have you write and, so here, write and graph the equation. All right. Ooh, not too bad on the writing, actually. That one's pretty streamlined. Okay, so we still have that same frame. We actually don't know, actually, well, let's actually define our variables. I'm sorry, we'll do that first. So let's let C be the total cost. So that's everything. That's the $200 fee plus the $18 per person. And let's let P be the number of people that they serve. Okay. Well, again, we have that frame. We want the total cost. Okay, whatever the total is. In this case, it's cost. So we're going to have C is equal to. Now we need our rate. Okay, anytime you see per, that usually indicates rate. It's $18 per person. So we're going to do 18 times the number of people, which we don't know yet. And then we did have that one-time fee of $200. So this is what our equation looks like. So now we're going to go ahead and graph this. Now, when it's a real world situation, we like to make sure we label the axes. So I will definitely do that. So on the bottom here, this axis is number of people. So I'm going to label it number of people. And this axis is the total cost. And the variable that we're using is C, so we can put a C there. Okay, so let's have, let's go ahead and go by maybe 50s on the side here. So 50, 100, 150, 200, 250, 300, 350, so on. Okay, number of people. Let's go ahead and go by 5s. Actually, we're going to run out of room pretty quick if we do 5s. Let's do it anyways. I probably should have made this scale more of like each square being 100, but I think we can still roll with this. Okay. Well, in this case, we know that 200 is our y-intercept. That is that one-time fee. Once you've agreed to have that person cater your event, you're gonna have to pay $200, even if nobody comes, okay? Now I'm actually gonna use like a little input-output table to help me with this. Because it's the 18, the numbers are gonna be a little bit off. So I'm gonna come over here, and I should use the same variables that I have here. So this will be number of people and total cost. So if I did 5 people, okay, then 18 times 5 is gonna be 90 plus 200. So this will be 290. If I invite 10 people, this is gonna be 180 plus 200, so 380. If I invite 15, we're basically adding another 90 every time we go over. So this is going to be 470, 560, and already we've kind of maxed out on our graph, which is what I thought would happen. Okay, so we're gonna go ahead and graph these. It's gonna be approximate. So I'm gonna say that's 290, and then 380 is right about here. 470 is right about there. So you can see what's happening. And if I had used a different scale, we would have been able to see more of the graph. But then you can use this to answer questions. You know, obviously our y-intercept here, let's write some stuff down. This is in this case, the y-intercept represents the one-time fee. Okay. And then in this case, the slope represents the cost per person. Now, if I wanted to find out how much it was going to cost for 50 guests, I could plug 50 in here and simplify it and find out what that total cost is going to be. And if I had done my graph a little bit better and used a different scale, I could actually go over to 50 and go up and see approximately how much it would cost. Graph is going to be hard because you're using a large scale, so you won't get an exact amount, but you get it kind of close. But if you want to know the exact amount, you would plug in 50 there for that and then simplify it to find out that cost for 50 people. All right, well at this point, I'm going to let you guys get your practice done. Like I said, make sure it's done on graph paper so that you can write your equation and then also graph it. And I hope that helps. Tomorrow we're going to review to make sure that you're ready for your quiz on Friday. All right, guys, send me an email if you have any questions, and I'll see you tomorrow.